So in the earlier classes, we have covered source transformation, star delta, mesh analysis and nodal analysis, right? Now today, now the next we are going to start today, that is known as Thevenin theorem. Okay, so what is basically a Thevenin theorem? Thevenin is a scientist name, okay, and on the basis of his name, he gave this theorem. First thing. Another thing, if you know about the Thevenin theorem, then only you will be able to understood any another theorem. Like apart from the Thevenin theorem, you will have maximum power transfer theorem also, right? So if you'll be able to solve Thevenin theorem, then only you will be able to solve maximum power transfer theorem, otherwise not. So now from these three theorems, one question will definitely come. Okay, maybe from the Thevenin, maybe from the superposition, and maybe from the maximum power transfer theorem. So now today we are going to study about the Thevenin theorem. So we'll follow certain steps for this. Step number 1, that we have to find out the value of load resistance. Okay, what is basically a load resistance in this? In whichever branch we need to calculate the current, that is known as load resistance. Okay, like suppose RL is the load resistance, and they ask you, like suppose this is 10, 4, 6, 8, 2. Suppose they ask you to calculate current in 2 ohm, okay, by using Thevenin. So what is RL over there? RL is equal to 2 ohm. Understood? Step number 1. After that, first understood, then you can write it down. After that, step number 2, you need to do open circuit RL. Okay, RL must be open circuit. And how will you do open circuit? Open circuit means you simply remove it. Correct? You simply remove this RL like this. This point is A and this is B. Step number 2 is also done. Now, step number 3, you need to calculate Thevenin voltage. Thevenin voltage is also denoted by VTH, and we can write it down as VAB also. Okay, Thevenin voltage is denoted by VTH, and we can also write it down as VAB. Understood? Now, ultimately, you need to calculate voltage across A and B. As you can see that there is no direct connection between A and B, right? So you'll need to move from A to C, C to D, and D to B. Correct? Just imagine that you are standing at A position and you need to move towards B position. Okay? So you can choose the longer path also, this one. But why will you choose longer path? But if shortest path is available. Correct? So VAB, can you write it like this? VAC plus VCD plus VDB. Yes or no? According to Ohm's law, VAC is how much? IAC into RAC. VCD is how much? ICD into RCD. VDB is how much? IDB into RDB. Correct? So now tell me, is there any current flowing through the open circuit wire? Yes or no? Will there be any current flowing through open circuit wire? No, now. If there is an open wire, then obviously there will be no current. If there will be no current, then IAC would be 0 or not? This is 0. ICD, we don't know. How much is the value for RCD? 6 ohm, right? Now IDB is also 0. Correct? If you know the value of ICD, will you be able to get the value for VAB? And how will you get the value for ICD? By always using mesh analysis. Mesh analysis. Whenever you need to calculate the current through Thevenin theorem, and in this case, you need to use mesh analysis rather than nodal analysis. That would be easy. Okay. Now see, you are moving from C to D. So current should also move from C to D. Correct? Okay. So from this, by applying mesh analysis over here, we'll get directly the value of ICD as 1 ampere. We can substitute it over here. Then after solving, we'll get VTH as 6 volt. So finally, we'll get the value for VTH. Okay? Clear up to here? Now after that, step number 4. Okay? We need to calculate Thevenin resistance. ठीक है? Thevenin resistance is denoted by the term RTH. For this, we need to do certain steps. What was those steps? If there is a voltage source, then that must be short circuit. How will we do short circuit? If we'll have voltage source, remove it and then connect it with a very plain wire. But if you'll have the current source, then it would be open circuit. How will you do open circuit? Just remove it. Okay? Now see, generally students got confused ki how will you remember it like this. So just imagine that voltage source is your relative. Okay? Relative which you don't like. Like there are some relatives now who are regularly visit to our house and we don't want that they'll come. Yeah. If any of your relative that you don't like will come to your house, then what you'll do with them? You will open the door or shut the door? मम्मी पापा बाहर गए हुए हैं तो you will shut the door, right? And current source is like your friend. ठीक है? If current source is coming, so will you open the door or shut the door? For your friend, you will always open the door. Correct? So this is the case. If in this case we'll have only one voltage source, so I'm short circuiting it and then redraw the diagram at each and every point. That would be better. And in this case it would be 4, 6, 8. This is 4 ohm, this is 6 ohm, and this is 8 ohm. This is A and this is B. Now just imagine that you are standing at A position, you need to move towards B. ठीक है? 4 ohm, 6 ohm, 8 ohm, all are your friends. Like you are at your home and this is your college. You need to move from home to college and you want to meet of your friends also. If two of your friends are at the same path, that means they are connected in series. If two of the friends are at the different path, that means they are connected in parallel. Okay, so if you'll move from A to B, then you will start with the friend which is very far away from you. That is 4 ohm. Now tell me, 4 ohm and 6 ohm, they are at the same path or at the different path? Means can you meet both of them or you have to choose one of them? See, you are moving from A, then you are stuck here. Ki either you can meet to 4 ohm friend or you can meet to 6 ohm friend. Yes or no? So that means they are at the different path you need to choose. That means they are connected in parallel. 4 parallel 6. Combined it into a single resistance. Then again see the same thing. You are again standing at A. You need to move towards B. Now this resistor and this resistor both are at the same path. Means they are connected in series. Correct? So In this case, 4 parallel 6 and 8 ohm, they are connected in series, right? Because they are at the same path. You can meet both of them. So 4 parallel 6 is how much? 4 into 6 divided by 4 plus 6 and plus 8. If we'll solve it, it would be 2.4 plus 8, then it would be 10.4 ohm. This is the value of RTH. We got it. After that, last and final step, step number 5, ultimately we need to calculate current, and we are calculating current. So what we have calculated VTH and RTH. So voltage source and resistance, as you know, they must be connected in series with each other. And we have removed RL in the first step, right? We have removed the RL value now. So we'll connect back RL to the same position across A and B terminal, and we need to calculate current. So according to Ohm's law, I is equal to V by R. V is how much over here? VTH. R is how much over here? RTH plus RL, right? So we already calculated the value of VTH, that we got it as 6 volt, and we already calculated RTH. We can just substitute the value, and what was the RL which we have removed in the first step? That was I think 2 ohm, right? So plus 2. So this is how we can get the value for current, and that would be our final answer. So this is, yes, this is your paper question. This is from 2023, right? You have to calculate current in 10 ohm by using Thevenin theorem. So first of all, we'll need to open circuit it, and after open circuit it, we need to calculate VTH value, correct? Now just imagine you are standing at A and you need to move towards B, correct? So you can move from any direction. Either you can move it from left side or you can move it from right side. That's your choice. So mark this one as C, this one as D. So what we can write it for this, VAB is equal to VAC VCD plus VDB, correct? I'm marking the values. What are those? 40, 20, 10, 10, 20, 10, 10, right? A to C, nothing is there, 0, right? C to D, every time, as I told you, we have to take the second sign. So what is the second sign? Minus 40, so minus 40. And for VDB, how many meshes are there? We'll have 2 mesh. You are moving from A to C, C to D, D to B, so current would also move in the same direction. This one is I1, this one is I2. So positive, negative. So minus second sign 10, and as you can see that current, this 10 ohm is in the middle wall, and in the middle wall there is a flow of double current. From this side I1 is flowing and this side I2 is flowing. So it would be I1 minus I2. This is the value for VAB. Now, for getting the value of VAB, we need to get the value for I1 and I2, right? So as you can see that we'll have 2 mesh and 2 variable, 2 equation. From these 2 equation, we can get the value for I1 and we can get the value for I2, right? And after getting the value of I1 and I2, we can substitute over here. Then finally we'll get the value for VAB. Understood? So after calculating this, you need to calculate RTH. How will you calculate RTH? As I told you, for this voltage source must be short circuit. Load resistance to already open. Again, voltage source is short circuit. This one is already open, and voltage source is short circuit, and this is already opened, right? So 10, 10, 10 and 10. Now A and B. You are standing at A, you need to move towards B. Now tell me, how can we do it further? Now you can see that no resistor is connected in series and parallel. So this one, and this one, right? They are connected in star. If I'll say it, if there is star is like this, right? Why? Then if you convert it into delta, delta also would be opposite. है ना? If you convert star into delta, then delta is in this shape. But if you convert star y into delta, then delta would be in this shape. Correct? So always mark it points. Okay? Like suppose this point is A, this point is B, this point is C. So delta will always also be between A, B and C. Yes or no? So in this point, one of the resistor 10 ohm is connected with A, right? Another is connected with, let us consider, I'm considering it as XYZ. Suppose this is X, right? This is Y and this point is Z. Now redraw the diagram. This is one of the option. Another option, as you can see, that this 10 ohm and this 10 ohm and this one, it's in delta now. That, yeah, it's in delta. So that would be easy. If we'll convert it, see A point as it is, right? Then 10 ohm as it is. We didn't touch, right? B point as it is. Now this is in delta and we can convert it into star, right? So star can be like this. Okay? It's in delta position now, so we can convert it into star. See, one of the point is connected with this resistance, so I'm connecting here, and another point is connected with this resistance, so I'm connecting it here. Another point is with this resistor, so I'm connecting it here. So this is 10 as it is. Now what I change, this one is in delta position. Okay, ऐसे कर लो, it's in delta. So it would be how much? We are converting delta to star. So it would be how much? 10 into 10 divided by 10 plus 10 plus 10. That would be 100 by 30. 1 by 3 and 1 by 3. Sorry, 10 by 3. 10 by 3. Okay. Now understood? I'm redrawing this structure again. See, 1 point. Correct? And this 10 ohm. और ये यहाँ से ऐसे लगा लो, this 10 ohm, this 10 ohm, 10 ohm, 10 ohm, right? It is in which position? It is in delta connection. Correct? So if I'll redraw it further, अगर मैं थोड़ा सा और डिटेल में बनाऊं, like suppose this is point B, तो can I draw this structure like this? This is 10 ohm, ये वाला, this is 10 ohm and this is 10 ohm, right? इसको मैंने ऐसे ले लिया वायर को, simple. And now if I'll draw it, if I'll convert it delta to star, it would be 10 by 3, 10 by 3 and 10 by 3. Correct? So one of the point is connected with B, that I have connected with B. Another point, as you can see, another point is connected with indirectly A. So another I connected with A and another point I connected over here. Okay? This one and this one, they are at the same path. They are in series. Correct? So now if I'll redraw it again, A as it is, B as it is, 10 by 3 as it is, and if I'll connect it, then it would be 10 plus 10 by 3, will be added with each other, and then this 10 by 3, correct? This one 10 by 3. So now again 10 by 3 and this 10 plus 10 by 3, they are connected in parallel. If you are standing at A, you need to move towards B. Then in that case, this resistance and this resistance must be connected in parallel. Solve it, it will be converted into single resistance. Then after that, B is there, then 10 by 3. Then after this resistance which we have solved, or ye pehle wala 10 by 3. Now tell me, they are in series or in parallel? They are in further series. Okay, so it would be how much? You can solve it and then you will finally get the value for RTH. It's not easy question. After this you need to calculate current. You already calculated VTH, you already calculated RTH. RL is given in the question, correct? So now I am giving you one homework question similar to this only. Try to do it in your homework. There also you can stuck it in calculation of RTH. Okay, again this would be solved with the help of star and delta connection. So you, before that you need to make practice for star and delta connection. For this I'll send you notes also. In that file you will get solved question. Okay, so it will be easy for you to do practice. In this, find the current through 10 ohm, again by using Thevenin theorem. Okay, this one is 10 ohm, means this is A and B. Note it down.